This sketching one for beaker A. Just now beaker A is, what was it again? Beaker A is endo, right? Beaker A is endo. So endo, they absorb heat, right? That means the reactant is here. Before reaction is here. After reaction, the energy goes up. Can you see? Energy goes up. Why? Because this is endo. That means they absorb heat. The reaction absorbs heat. That's why the energy goes up. All right, and then for B, B is exo. B is exo. So in this case, the energy level will go down. Right, your reactant is here, your product is here. So your exo means energy go down. So because the energy is already released to surrounding. That's why for the reaction, the energy goes down. Okay, hope you understand. This is common sense. So explain in terms of energy changes. You know what? Write this yourself. This one, energy level increase, energy level decrease. All right. When we do graphs like this, we have to write reactant and product. Better be. Takkan you leave this empty, right? Because it will look really weird. So write something here lah. So reactant and product. Reactant are the things before your reaction. Products are the things after reaction. I'm sure you know this already lah. All right. Anyway, moving on. You know what? I'm gonna skip question 5. Please don't tell me you don't know how to read thermometer, Okay. If you do, then please go back to primary school. We skip. Okay, we skip. Okay, let's look at question 6. Okay, that's why I say I'm gonna do a few, then maybe I'm gonna skip a few because those questions are kind of repetitive. So let's look at question 6. Ooh, this is chapter 4. Wow, this is chapter 4. Hey, ask you guys, have you guys done this in school? Have you guys done this in school? Because I have heard a few students, they say, oh, sir, the day we burn calcium carbonate. Have you guys burned this? Have you guys done this? Oh, you guys have? Whoa, that's cool. That's cool. Oh, don't have, Finny, what school are you from? Finny, what school are you from? It depends on your school. Oh, BP, no wonder. Oh, you're from BP, That means you know Ashton there, lah. That means you know Ashton? You know, because I have PU here a lot of students, Puchong Utama here a lot of students from BP one. So you see our name list, you know many people from BP one. Okay. Oh, you know Jiajing and Winnie. Oh, okay. Oh, you're their friends? Oh, okay. Hey, I just saw them just now. They just attended my class just now. Wow. Oh, okay. Wow, small world. All right. Our boiling tube melting at the bottom. Boiling tube melting, Boiling tube can melt one, man. Boiling tube can melt one, man. You just realize the green screen. What green screen? What green screen? My green screen, My green screen, All right. Anyway, the glass melted, Oh, you want crack? Yeah, why so lousy one? Hey, guys, let me tell you something, Good quality boiling tube, will never melt. Okay, ask Rebecca. Ask Rebecca. Hey, Rebecca, what's up? Did you do the experiment? Hey, guys. Hey, this thing, let me tell you something, Good quality boiling tube will never melt. If that thing will melt or crack, that thing is a lousy brand boiling tube. Okay, that means your school is cutting costs, lah. Your school is cutting costs. Your principal, is doing some hanky-panky with the money. Okay. The money is supposed to go for the instrument. Maybe the money gone somewhere else. You tahu lah. Alright. Do you know this is how principals earn? Alright. Do you know how this is how principals earn? Crucible also broke. Hey, Crucible where can break one? Hey, Crucible can stand up to 1,000 something degrees. How can that thing break? Aduh. Ayo, mampus lah, your school's equipment, made in China one, is it? Made in China one, is it? Low quality one, is it? How can this thing crack? All right, anyway, so this thing, okay, when you burn calcium carbonate, okay, by the way, what is this? This was in chapter 4. Calcium carbonate is your limestone. Okay, limestone, batu kapur. In Mandarin, it's called shihui. You know, batu cave. Batu cave is from limestone. I mentioned this like last chapter already. Okay, magnesium powder harder inside the. You see, this is what happens when your school is like shit lah. Alright, they are not treating the specimen very well. They are not treating the instrument very well. That's why you get all kinds of messed up shit lah. That's why your experiments fail. This one I cannot help you. This one because your school sucks lah. That's the only explanation. Alright, anyway, so what is lime water? This is your air kapur. Okay, air kapur. Alright, so do you still remember this thing? When you burn calcium carbonate, what happens? Can you remember what happens when you burn calcium carbonate? Hey, you did this for those who did this in school. Do you remember what happened? Do you remember what happened? This calcium carbonate will produce carbon dioxide. Remember? Hey, very easy to memorize one. Okay, you see, carbonate, right? Carbonate is carbon dioxide lah. Okay, it will become gray. Yes, it will become cloudy. Yes, it will become cloudy. Okay, akan menjadi keruh. Menjadi keruh. So this is your calcium carbonate lah. Hey, very easy one. Okay, you know carbonated drink, your soft drink, 汽水 carbonated drink, inside your Coca-Cola, that's the carbon dioxide lah. That's why it feels very gassy. That's why you have bubbles inside your soft drink, because it is carbonated drink. 汽水, that thing is carbon dioxide. Alright, so when carbon dioxide goes into lime water, it will turn cloudy or keruh. That means the thing will look dirty lah. Okay, so anyway, so they want nothing to do with chapter 4 lah. They're just asking, is the heating of calcium carbonate exothermic or endo? Is drinking CO2 bad? No, you just burp it out lor. When you drink Coca-Cola, you just burp the extra air out, right? That's the carbon dioxide lah. Alright, anyway, so is this exo or endo? I'm heating it, right? So this thing absorb heat, right? So when this thing absorb heat, this is endo lah. Hey guys, this is the same concept as cooking. Cooking absorb heat, what? So this one absorb heat lor. Okay, absorb heat lor. So absorbs heat. So they want you to explain the answer. Why is it endo? Because they absorb heat. Okay, absorb heat. Menyerap haba. Absorb heat. And then one more mark, 3 marks here. So absorb heat, and then they will produce carbon dioxide. Okay, menghasilkan karbon dioksida. Alright, menghasilkan karbon dioksida. Okay, Savannah, is your internet okay? Your turn to disconnect. Alright, so next B, differentiate the reaction. Differentiate means bezakan lah. They want you to tell the difference between hydrochloric acid and sodium carbonate, and the reaction between hydrochloric acid and sodium hydrogen carbonate. Okay, that means these two reactions got what difference there? Got what difference? Very easy. They also asked like that already ma. So this is exo, this is endo. You might say, walao sir, how do I know this is exo? How do I know this is endo leh? You don't, because you haven't learned this thing. Alright, because that's the way they are. Hey, you know what is this? You know, it's sodium hydrogen carbonate. This thing is actually your baking soda. That's a scientific name for baking soda. Wow, how do I know, laser? This thing so complicated. Well, of course you don't. That's why this is not coming out in exam. You just learn for fun. Alright, anyway, next. Diagram below shows the heating of a strip of magnesium ribbon. Now you heat magnesium. Hey, this is chapter 4 also. Hey, you guys got burn magnesium? You guys got burn magnesium? Do you see like a bright light happening here? When you burn magnesium, you will see a very bright light. Like this thing will hurt your eye. Have you? Anyone of you done it here? If your teacher knows what she's doing. Oh, she did. Do you see the bright light? Did you see the bright light? No, no. Oh yes, then good lah. No means you become God for 10 seconds. What? Why? Why become God for 10 seconds? Hey, this thing was used in where, you know? They were used in your camera flash. Let me show you. Let me show you this one. Are there? This was the camera flash last time. This is magnesium lah. This is magnesium. Hey, you know where else? They use it in flare. You know what is flare? You go play Call of Duty. You go play any shooting game. This is flare lah. When you're looking for help, signaling the helicopter, you use the flare lah. This is magnesium. Stupid bright, man, this thing. I mean, if yours succeeded lah. If yours failed, I don't know what the hell happened. Okay, maybe your teacher lousy, don't know what to do. Okay, so is this, did the chemical reaction happen? Yes. Okay, why? Because this is endothermic. Because absorb heat, same like up there, lor. This is endo when I burn it. So this is endo when I burn it too. Same thing. Okay, guys, if you burn this thing, try not to look at it with your eyes, straight eyes. Okay, please wear sunglasses or something because this thing is going to hurt your eye. All right. Anyway, moving on. So what conclusion can be made from this reaction? Magnesium is a reactive metal. Not really related. This reaction is exothermic, no. High boiling point, no. This reaction is endothermic. So this is the answer. Okay, can I? Easy peasy, All right, next, moving on, let's go into our question 7. Ayo, why is it the same question again? All right, okay, let's get this done. Okay, so burning of petrol is exo. Okay, photosynthesis is endo. Respiration is exo, because you become hot, your body heat. Making bread, endo. And then neutralization, exo. Rusting, I did say it's both, right? We put it endo here lah. Because 3-3 fair for everyone. You 3, I 3 lor. All right. Anyway, so D, underline the correct answers. The burning of a candle is exothermic because heat is released. Exo, exit. And then number 2, exothermic reaction in the body increase your body temperature. That's why you become hot, right? So number 3, exothermic reaction is applied in hot pack. It make everything hot. So number 4, baking a cake is not an exothermic reaction because heat is absorbed. Same concept lah. Same concept. All right, let's go to question 8. You know what? I'm getting a little sick of this chapter because it's so easy. All right, so let's look at chapter 8. Question 8. So this is your hand warmer. This is a hot pack. So table below shows the changes in temperature for chemical PQR. Okay, so P, the temperature increased by 5 degrees. And then Q, temperature increased by 3 degrees. So they put an X here. And then for R, temperature increased by 10 degrees, so it becomes 25. So what is the final temperature X for reaction Q? Wow, is this kindergarten question? So 13 plus 3 is... Don't you feel humiliated doing question like this? It's like asking you, are you stupid? All right, so 16. So B, name the reaction that release heat to the surrounding. Exo lah. You get my point now? Why is this chapter so repetitive? So C, which of the reaction PQR is suitable to be used to make hot pack? Explain your answer. So if you're making a hot pack, which one would you choose? Of course, you would choose R, right? Because the temperature increased the most, okay? It is the most exothermic reaction. All right, tindak balas yang paling exothermic. This is the most exothermic, that's why you use that. I mean, 10 is still pretty lame lah, Come on lah, if it is 15 to 25, you can barely feel a thing lah. I mean, yeah, you feel it a little bit warm, but that's all lor. Hey, heat pack needs to be hot one Heat pack needs to be like 50, 60 degrees one At least make it warm lah. I mean, only 50 or 60 can feel it warm. What is 25, man? Okay, this would make a very lame heat pack. Okay, so D. Instant heat packs are often used to heat up the body in cold climates or to treat certain injuries with heat. When a heat pack is pressed, it becomes hot. What is the type of reaction? Yeah, exo lah, write this yourself lah, okay? Ayo, same question again. Alright, so number 9. Okay, let's skip to number 9. David needs to perform an athletic training for running. So this is the ammonium nitrate. This is the cold pack lah. This is the cold pack, and then they put water inside, and then there's a thin film inside, like I said. Alright, so the instant cold pack needs to be squeezed before use and break the thin film lining, which is between the ammonium nitrate and water. So what happens when the thin film lining breaks after being squeezed? So the temperature will decrease. Okay, suhu menurun. It becomes cold, right? So what is the type of reaction? This is endo. Absorb heat ma, so endo lor. So how the instant cold pack work based on your answer? Yo, same thing lah. Endothermic, absorb heat. You know what? Skip. Skip. All right, let's look at number 10. Okay, question 10. This is so-called a K-bar question. Okay, this is the K-bar question. So they want you to make a hot pack and a heat pack using these things. All right, you might say, what the hell, sir? what are these? They will give you a big zip bag and they give you a small zip bag. Okay, and then they give you water and toothpick. They give you ammonium nitrate and calcium chloride. So you already know lah, ammonium nitrate is endo, right? This is to make cold pack, right? And then calcium chloride, this thing must be exo lah. Okay, this is to make your hot pack. So what do you do? This is so lame lah. You take a big bag. Okay, this big bag here, you put a small bag inside. And then the small bag inside, you put ammonium chloride. Nitrate, sorry, ammonium nitrate. And then the outside, you put water. So when you want to use this bag, what do? You take the toothpick. You have to use the toothpick because they give you. So you use the toothpick, you poke a hole in this bag. So this thing will react with the water, and then you get a cold pack. Can you see how lame this is? So-called K-but. I mean, what the hell? All right, so if you want to make a hot pack, then you do the opposite. Okay, you do the opposite lah. You put calcium chloride. Ayo, what the hell? This is so lame. Okay, calcium chloride, and you put water here. So what happens when you want to use it? Same thing lah. You take a toothpick. You put a hole here lor. So lame, right? Then how ice pack works? Ice pack, what do you mean ice pack? The ice, ice pack, you get it from frozen water. Okay. Or the gel one, okay. The one you just put in the fridge. The one you just put in the fridge. Guys, if you don't want to use those, just now the cold pack, it's one use one. Okay, if you want the reusable one, you buy this thing. You buy this thing. That's the cold pack. That's a cold pack. Hey, they sell this in pharmacy, right? You go Watson, they will sell this thing. I think it's like $15 or $20, right? 15 or 20 bucks. Then you just put it in the fridge. They put it in the fridge. And this one got two use one. They can either be a hot pack or they can be a cold pack. So if you put it in the fridge, they become cold pack lor. If you soak it in hot water, then the thing becomes a hot pack. Okay, I have this at home. I mean, you should have this at home. Because you see why? Like I said, it's good for treating injury. If you have bruises, it's good for, let's say you burn your hand holding a pot, you can use this thing. Okay? Just put it in the fridge. Just put it in the fridge. What do you mean how? Okay, Elian, what do you mean how? They just absorb. The gel inside can stay warm for very long, or they can stay cold for very long. That's why they can become a hot pack or cold pack. That's how it works. Okay, that's how it works. So inside the gel, this thing is reusable many times. My heat pack has been in my fridge for 10 years. The thing is still working because the gel doesn't expire, so you can just keep using it. Okay. Anyway, so I think that's for our chapter lah. This is exo lah, do it yourself lah. This is your exothermic. Okay. When you soak detergent powder, her hand becomes hot. Her hand feels hot. Why? Because this is exo lor. Okay. And then this is the bombardier beetle. Alright, they release hot and toxic spray towards the predator. Now, what is this reaction? Exo lah. I sound like a grandpa already, okay? Repeating the same thing over and over again. All right, anyway, we have some time. Let's go into chapter 6, shall we? Okay. I know we are supposed to enter this next week, but hey, we have a bit of time. Let's go to chapter 6. I'm not sure whether you have this note already. You have a tuition. Yeah, sure. If you want to go for another class, then please you can do so. Okay. Anyway, let's look at our chapter 6. Guys, can you see the great news? We are back at electricity. Yay! I mean, yay for me lah, because I really like electricity. For girls, you're like, oh my god, this shit again. Right? Do you remember last year? When you learned that Ohm's law? You remember what it is? What is your parallel circuit? Sorry, series circuit, Lita Bersiri, and your parallel circuit, Lita Solari. Do you remember this thing? I mean, it's the stuff of nightmare, isn't it? Hey, I don't know why girls, can anyone enlighten me? Why girls, y'all hate electricity so much? What's with this chapter? I mean, there's nothing to memorize. It's easy to do. I don't know, it's easy everywhere. Why do you hate this chapter so much? I really don't get it. All right. And okay, if you find last year's electricity very boring, I get it. But this year's electricity, it is much more interesting because we'll be learning how to generate electricity. Okay, what's your power station? What is AC and DC? Have you heard the story of Edison versus Tesla? Guys, anyone? Have you heard of the story of Edison versus Tesla? You know who Edison is? Thomas Edison. All right. Many of us believe he's the king of invention. Okay, not the Edison lah. Okay, Thomas Edison Okay, he's a major asshole, man. Okay, Thomas Edison. Do you know this fella? Thomas Edison, so-called the inventor of light bulb lah. Guys, he did not invent the light bulb. He took someone else's design, he improved it, and he copyrighted it, and he earned billions from it. He's a major asshole. All right, and he actually pushed for DC. All right, whereas Tesla, the genius behind AC, okay, he pushed for AC. All right, because Nikola Tesla, he actually believed that AC is the future. All right, he believed AC is the future. And you know what's the sad story? He died alone and poor. Okay, he died alone and poor, while Edison, that asshole, that prick, he died a billionaire. So can you see how is this world not fair? All right, you are using AC today because of Tesla. Without AC, we wouldn't be able to use electricity. So I'll tell this next week. All right, this is a very interesting story. All right, and Edison actually used a lot of money to defame Tesla. They even got rap battle. Oh, you go watch that, Oh, you go watch that, Okay, that's cool. That's cool. All right. Anyway, so DC and AC lah, and this week, you'll be learning about what is transformer, not the robot, Transformer. You have this thing in your charger. They will take high voltage and then they will step it down to low voltage. That's why you can charge your phone. All right. We'll learn about this soon. And then how does your national grid network works? Okay, this is how our electricity is supplied to our country, right? Whole Malaysia, we supply energy using this way. We will learn this. And you know what is this? You know this meter? You have an electric meter outside your house, right? Do you know that? If you use electricity, you can see the thing turning. How do you get your electricity bill? They will look at your meter lah. All right. And some people they go and modify this thing so that they can turn slower so that they can pay less bill lah. You know that? That's your electric meter. And of course, there your pin. What is 2 pin and 3 pin? Okay, a very interesting chapter leh. And then calculating the cost of electricity. This there. Have you seen this sticker before? I'm sure you have this on your fridge or your aircon. All right. And how do you calculate your electric bill? Next, your note is BM one. Oh, okay. I'll send you the BM later. Yours is BM. Wait, Fini, are you using BM or BI? Are you using BM? Oh, you're using BM, Okay. So if is your note in BM? Is your note in BM? Is your chapter 6 in BM? Oh yes, okay, then later the chapter 5 I'll send you the BM one. Okay, anyway, so let's look at our generation of electricity. Okay, we don't have much time today. I will just talk a little bit about this. This is called penjanaan electric. Alright, so how do our electric comes from? Okay, where do they come from? How do we make them? So we make electricity, we generate electricity using two ways. You can either use renewable or non-renewable energy. You know this, right? Tenaga yang boleh diperbaharui, kekensing 能源, and non-renewable, tenaga yang tidak boleh diperbaharui, 不能更新的能源. You heard of this thing, right? All right. Okay, let's talk about generation of electricity. How do you generate electricity? Is by using a generator. You know, it's a generator. In Mandarin, it's called 发电机. This is how a generator works. Okay, you know, last time when they cycle, when they use a bicycle, when they cycle, they have headlamp, right? And when you stop cycling, the headlight will stop. So when you cycle, you are turning the generator. All right, a generator. Okay, let's say this is a generator. A generator has a fan-looking thing that we call a turbine. Okay, turbine. In Mandarin, this is called 螺旋桨 turbine. Okay, it looks like a fan. So when you turn this turbine, this thing is connected to a magnet inside the generator, so the magnet will also turn. When the magnet turns, you will generate electricity. This is how it works. All right. So let me show you this. Okay, a simple generator. This is your simple generator. Hey, it looks like this. It looks like this. You see, you just need to turn this thing, and then you will see light. Can you see? You can turn it, and then you will get electricity. This is your generator. Okay, this is your generator. All right. You might say, sir, this is a small one. What about a big one? Even a big generator, okay, even a big electric generator, it's the same. All right. The concept is the same. You see, is this generator big enough? All right, is this generator big enough? They work using the same way. They work using, okay, the bicycle one is the same thing. Okay, let me show you the bicycle generator. It's the same, they're just turning the turbine. Okay, the bicycle generator, where is it? Hey, why? Something like this, something like this. Okay, hey, if you are good enough, you can actually cycle to power your laptop. Okay, so the house thing is also a generator. What do you mean house thing? What house thing? You mean the TNB house looking thing? That is not a generator. That thing is a substation. Generator is very far away. All right, I'll talk about it next week. All right, so how do you turn this turbine? So there are many ways. You can use hydro. What is hydro? You remember what you learned this in geography, right? You know, it's embangan. When you build a dam, embangan, and then when the water flush down, the water will turn this thing, so you get electricity. This is how Malaysia we have hydro. You can use wave or tidal. Okay, one is ombak, one is pasang surut. This one is by using seawater. When seawater they come up and down, they can turn the turbine. We don't use this. France, they use this. France, they use tidal. Okay, solar is the only one that doesn't turn turbine. You know what is solar, right? Solar, we use the thing called solar panel. You know solar panel, some people they install it on their roof, then they will get electricity. All right, and the thing is free. All right, solar is free one. And then of course our wind energy, we use windmill. Okay, the 风车 windmill turn this thing. All right, biomass is by burning dead animal. Okay, dead tree leaves, animal shit or whatever. We burn the biomass and then we turn the turbine. Okay, when we burn something, we create steam. We can cook water to steam, so steam can turn this turbine. All right, geothermal. This is in like volcano country like Iceland, Greenland. They will use their hot spring to turn this thing. Okay. Oh, is it? Oh, is it? Oh, okay, okay, interesting. I think that's in France, right? I think it's in France, right? Because mostly tidal is in France. All right, so these energy, they will never run out. They will never deplete. Tidak akan kehausan. You can use this forever. But these things, they will someday be finished. All right, so for example, you have your nuclear, and these three, if you still remember, they are called fossil fuel. Bahan, api, fossil. That's your dead animal, dead dinosaur, dead whatnot. So coal, natural gas, and petroleum. Okay, these are your fossil fuel. And do you know what's let you know a fun fact. The electric you use at your home right now, 80% comes from fossil fuel. You see? Can you see the problem right now? Can you see the problem right now? Burning fossil fuel is a very bad thing for the environment. When you burn fossil fuel, you create carbon dioxide. You cause greenhouse effect, kesan rumah hijau, and then you cause global warming, pemanasan global. We are 80% dependent on this. Then you say, sir, then we burn less fossil fuel lah. We don't burn this lah. You thought so easy Okay, some people they say, sir, why not we change everything to renewable? Because renewable, they are not reliable. They are not very good. Okay, if they are so good, we are using them already. Hey, only 6% of your energy comes from hydro. That's not a lot, isn't it? All right, 80% comes from fossil fuel. So this is why if you switch off your aircon, you switch off your light when you're not using it, you burn less fossil fuel, you are actually saving the world. You are saving Earth. So you are saving fossil fuel. All right. So you know what? I think I'm gonna stop here. Next week, okay, I will continue with this lah. So that's it for today, guys. Okay. So happy Thursday to y'all. I shall see you the same time next week. All right. So take care. Good night to y'all. I will see you and bye bye.